Good day, everyone, and welcome to the GMAT 41's Organic Chemistry class. In our class today, I'll be teaching you the IUPAC nomenclature of another homolog, the alkanols. If this is your first time of visiting the GMAT 41's YouTube channel, kindly subscribe, turn on the notification bell so as to follow up with my updates. Remember also to invite your friends, your colleagues, so that they can like and subscribe to the GMAT 41's YouTube channel as well too, as we continue to do our part to contribute to your academic success. When dealing with alkanols, this is another homolog in organic chemistry. We also refer to them as alcohols. Remember, our interest is to deal with the IUPAC nomenclature of these homologs. Previously, we treated IUPAC nomenclature of alkynes, and I told you that in our next class we'll be moving on to another dimension in terms of how to give the IUPAC name of this homolog, alkanols. Well, before we start up, I'd like you to take a look at these two, because one of them is the correct pattern in which we handle the parent name of alkanols. So, in terms of breaking the prefix from the suffix, my question is, do you think it is alk XO, or do you think it is alkan XO? Then that's just a new concept we are going to add. Are you following, right, to our study of the IUPAC nomenclature of alkanols? Every other rules will follow what you already learned from our previous classes: alkane, alkene, and alkyne. And without wasting time, I'm going to tell you the second pattern is what we deal with, or what we adopt when dealing with IUPAC nomenclature of alkanol. In breaking the prefix from the suffix, please take note, it is alkan XO, where of course that X indicates the position of the carbon atom bearing the functional group of alkanol, which is OH. Correct. Having said this, we will be moving on straight ahead to our first structure. We want to learn the IUPAC nomenclature of this structure here on the board. Alright, so this is the first structure given to us to name. And how do we go about it? Remember the usual rule. We have to determine the operating functional group in this structure, because that will help us to know the homolog that this structure belongs to. And clearly the functional group here is this OH. Are you following, right? Telling us that this is an alkanol. The longest carbon chain is the next thing we check, and clearly from here you can see that there are 3 carbons, okay, in the longest chain. 3 carbons. As an alkanol, we have the prefix propane. Then indicate the position of the carbon atoms bearing all the OH you have there in the structure, if there are more than one OH, as the case is for this structure. Conclude with all. But if we have more than one OH, of course, you need to indicate how many of the R's we have, because the OH there actually brings the concept of R. That's OL. Anyway, let's move on. My counting can start from anywhere in this structure. You know the reason for that? The functional group OH, whether counting from the left or the right, okay, it is seen on carbon number 1. Then even this OH you see here is symmetrically placed, because it is on carbon number 2. From either the left or the right. There is no attachment, no substituent in this structure. So I can clearly start my counting from anywhere. I want to go this way. So this becomes propane 1, 2, 3. Because there are 3 OH there, we are going to get tri-R. Good. This compound is also known as glycerol. Anyway, that is not what we are dealing with. In this class, we just focused on IUPAC nomenclature. Remember, for detailed learning of alkanols and other homologs in terms of their chemical properties and their methods of preparation, you can contact GMAT 41 to join our full range of learning classes on our Telegram channel. In the comment section, you have the links, all right, in order to get information more of how to join our classes. Let us move on to our second structure, number 2. And this is what we've got in our second structure. Okay, so first we have to identify that this is an alkanol because of this OH, which of course is the functional group of alkanols. And having identified that this is an alkanol, we have to proceed to find out the longest carbon chain so as to get to know our parent. And a clear observation tells us that the longest carbon chain is good. I'm saying 5 here. You go 1, 2, 3, 4, 5. Or 1, 2, 3, 4, and 5. Okay, I would like to take this as the longest chain so that this becomes attachment. Is that okay? So let me indicate attachment, attachment, and attachment. That's substituent. Now, if you look at this, we have our OH on the third carbon atom, whether you count from left to right or from right to left, which simply means that this OH is symmetrically placed. It is placed in such a way that it divides the parent chain into 2 equal parts. Because on the left of this carbon bearing the OH, I call this the carbon of the functional group. On its left, we've got 2 carbons, and on its right, we've got 2 carbons as well too. So the functional group is symmetrically placed. In terms of alkanol functional group, talking about maybe divides the structure into 2 equal parts, that can occur when we have odd numbered carbon atom. Odd numbered carbon atom. If you have even number, there is no way that functional group will be symmetrically placed. Take note of that. This statement I made now is opposite to what you learned under alkenes and alkynes. In cases where the double bond or triple bond for alkenes and alkynes respectively, are you following right, is placed in such a way that it divides the structure into 2 equal parts, that happens in cases of even numbered carbon atom as the longest chain. Alright? Because the double or triple bond occurs between carbon atoms. So in that case, it happens when we have maybe something like even number of carbon atoms in the parent chain. But in the case of alkanols, this OH, the functional group, is not between carbons per se, like somewhere here between 2 carbons. No, it is directly on a particular carbon. So in a case where the functional group of alkanol OH is symmetrically placed, that can happen when we have odd numbered carbon atom. Anyway, let's move on, please. I just had to make a reference to what you've learned previously, which is a bit opposite to this. Having said this, observe that the direction to count this from would be from the left to the right. You know why? The attachment site first is seen on the second carbon atom from left to right. But if you're counting from right to left, you cite the attachment first on the third carbon atom. You notice that I am no longer talking about where the functional group OH is closest to for this structure. Okay, I'm now using where I cite my attachment first. Of course, you know the reason already. The OH, if it is based on it, counting can start from anywhere. Are you following right? But now that we have attachment, that attachment will now guide us to know where counting will start from. Like I said, it's from left to right. So on the second carbon atom, you've got this methyl attachment. H3C is the same as CH3. And then on the third carbon atom, we have this ethyl attachment, and of course, the functional group OH. The parent name, the prefix will be pentan, because there are 5 carbons. In fact, let me indicate that. This is carbon number 5. Pentan, position of the carbon atom bearing the OH, then you conclude with O. So we go. Attachments mentioned first. This is methyl, this is ethyl. So we have 3 ethyl because ethyl will come before methyl. Then 2,2-dimethyl. There are 2 methyl attachments on the second carbon atom. 2,2-dimethyl pentan 3-ol. That's the name of this structure. This is wonderful. We shall be moving on next to another structure, number 3. Wow, this third structure is crazy somehow, right? You're wondering, how do we handle this? Well, this double bond makes the structure a bit complex because all the things we've been saying as bonds in structure number 1 and 2 were all single bonds. And so this made the structure quite complicated and just scare us. Don't worry, GMAT 41 is always right beside you to guide you. We are going to use the knowledge of the known to handle the unknown as we've seen on the board here. It's interesting to say this, please, because we've treated this functional group, double bond, okay? And so I want to believe that by now, as you may have learned under alkenes, if you decide to take this OH as an attachment and then end the parent name of this with alkene, you should be able to do that, okay? Based on our previous knowledge. But anyway, what we are treating is the homolog alkanol. So I'm going to name this structure respecting alkanol as a functional group. Meanwhile, let me say this, that this structure can either be named as an alkanol or as an alkene. So it has two possible names that can be given to it. Okay? And the reason why we can name this as an alkene is because this OH, alkanols, they are functional group. They must not be a terminal functional group. As a matter of fact, are you following? Apart from, let's say, primary alkanol in terms of classification of alkanol, like I said, all these concepts, please, to get full range of learning, you can join our Telegram channel. Check the comment section, you'd get the link to guide you on how to join our full range of learning classes. Okay? Now, having said that, I am saying to you now that this OH as functional group of an alkanol is not a terminal functional group. It can only be a terminal functional group when the OH is seen on carbon number 1. And that happens for primary alkanols when you are dealing with classification of alkanols. Now, because the functional group of alkanols generally is not a terminal functional group, it means that if I see OH in any structure, I can actually decide to take that OH as a substituent and then give the name of the structure respecting another functional group that I see there. Please, let us proceed to deal with this. I am going to treat it as an alkanol, then perhaps I will also show you how this could be an alkane, which I believe you have the idea already. So, as an alkanol. Now, as an alkanol, it means we would respect this OH a lot. First, counting will start from where the OH is closer to. Are you following, right? Which clearly in this case, it is closer to the right than it is to the left. And then the longest carbon chain, as you can see here, there are 6 of them. On the second carbon atom, we have the OH, and then on the fourth carbon atom, we have this double bond. If I am naming this structure as an alkanol, please note that the double bond, which is representing the the alkene, are you following? It will occur. It will appear as a sub-attachment in the parent name of this structure. This is 6 carbon atoms, we know that, okay? So that alright, will appear as a sub-attachment in the parent structure. And the name goes generally in this format, respecting that this is an alkanol. It goes as alk, YE, XR. Once again, alk, YE, XR. That's how the name would go. I guess I made reference to something like that when we treated alkenes. Anyway, you can refer back to it. So we move on. The longest carbon chain, we said 6 already. No major attachment here. Are you following? No major substituent. And that 6 carbon atom will have the prefix hex. Is that not so? Hex. Remember I told you it's going to go as alk, YE, XR. Y and X represent the position of the carbon atom bearing these functional groups mentioned. So let us go, please. Hex. So on the fourth carbon atom, we have the double bond. So it's going to appear as a sub-attachment in the parent name we are giving. So hex 4E. Then hyphen. On the second carbon atom, we have the major functional group we are treating, which is the OH. That's in the second carbon atom, you indicate it. So you have 2, you conclude with what? Or. This is how we handle structure like this, taking it as an alkanol. You notice that we ended it with "or", so that tells us that we've respected this structure to be an alkanol. Permit me, please, to handle it as an alkene this time around. You know, that being the case, the OH will now become a major attachment in the structure. The parent name, the suffix will now end with "in". For that, the counting will start from the left to the right. Reason: the double bond is closer to the left than it is to the what? Right. Remember, we are respecting this structure to be an alkene now. So we're going to have on the second carbon atom, we have this double bond, because after carbon number 2, starting from here, you see the double bond. And then 3, 4, 5. On the fifth carbon atom, you have the OH. So OH as a major attachment will now become 5-hydroxyl. Then the parent name, 6th carbon atom, will now be hex. You break it there. And then on the second carbon atom, you have the double bond, which is 2-in. 5-hydroxyl, hex, 2-in. Correct. So these are two alternative names that this structure can have. In objective case, the option will tell you which of them to go for. There is no way they can give you the two of them, alright, as options in a given question. But if it is in theoretical case, we can provide these two names as alternatives. While explaining the reason why this structure can still be taken as an alkene, you heard me say something like terminal functional group. And of course, I do understand. Alright, once as a student, I might be wondering, what does this person mean by saying terminal functional group? Are you thinking about that too? Don't you worry, we are going to meet that concept of terminal functional group when we treat the IUPAC nomenclature of alkanols, aldehydes, as well as the IUPAC nomenclature of alkanoic acids. Alright? Make sure you follow us up so that you don't miss that class in order to get better understanding of what terminal functional groups are and their implication when dealing with a IUPAC nomenclature. Good. Now we are moving further to the fourth structure, which of course is going to be the last structure we'll take in the class, IUPAC nomenclature of alkanols. This is our fourth structure. Identifying the homolog that this structure belongs to, we can see clearly that this is an alkanol because of this OH that we have there. Is that okay? This is an alkanol, and so I have to determine the longest carbon chain. And without any doubt, counting will start from here because this OH is clearly seen on the first carbon atom here. Are we together? As a matter of fact, let me say that this is a primary alkanol. Okay? Structure number 2 we treated is tertiary alkanol. Structure number 3 is secondary alkanol. And this one is primary alkanol. Anyway, we are not talking about classification of alkanols, so I wouldn't talk about that. And this OH, you can see, is on the first carbon atom here. Okay? Yes, because this OH is attached to an end carbon. That makes that carbon number 1. Because in this case, this OH will be serving as a terminal functional group here. Like I said when I was explaining structure number 2, apart from the case where the OH is on carbon number 1, in all that cases, the functional group of alkanol OH is never considered as a terminal functional group. Well, let's proceed. Counting will start from this carbon because that is where we have the OH closest to, on carbon number 1 there. And so looking at this, I can go this way and check, or I can go this way and then check to get the longest carbon chain. And I think from what I'm seeing here, if I go this way, 1, 2, 3, 4, 5, 6, then 7. This way, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So the longest carbon chain is 7. I want to emphasize on this once again, although under alkanes, alright, IUPAC nomenclature of alkanes, I made reference to that, and so you can refer to it for further reminder. This is the longest chain we said, but if you look at this carbon, it appears to be the last carbon in the chain in this direction. And then you now have this CH3 as a branch there. Please, since this is the last carbon, and then to read, you're now having this CH3 as a branch, this CH3 is not an attachment. It is not a substituent. Rather, it is a continuation of the chain. So we don't stop here as number 6 and then say that this is an attachment. No. It's a continuation of the chain. Suppose maybe there's another CH3 this direction. We can now say, okay, either this one is an attachment, this is continuation, or this is an attachment, then that one is a continuation. But in this case, once again, this is a continuation of the chain, not an attachment. Like I said, I already talked about that under IUPAC Nomenclature of alkanes. Let us identify our attachment. This is an attachment. Now if you come to this whole unit is also an attachment. And from what I'm even seeing from here, this carbon is directly attached to this parent carbon. Are you following, right? So from here we can renumber this as carbon number 1. And then go this way, that as number 2. This becomes an attachment on an attachment. Or I can go this way and this becomes an attachment on an attachment. I would like to go this way. 1, 2. So this becomes a substituent on substituent. Side chain attachment. Alright, so this is carbon number 1. We have 7 carbons here. 1, 2, 3. On the third carbon atom here, we've got this attachment, number 3. Place this CH2 is meant to be CH. With this 2 here, you observe that the structure is wrong because you have more than the required number of bond lines around this carbon. Let me show you so that you get to correct any structure that have a problem like that. This is 1 bond, 2, 3. Then this H2 indicates 2 extra bonds, making it 5. And you know that we stated when we started a IUPAC nomenclature study that a carbon is meant to be surrounded by how many bond lines? 4. Not less than 4, not more than 4. So this is supposed to be CH, not CH3. Good. I think it's correct now. This is carbon number 4. So we have attachment on carbon number 3, carbon number 4. Let us analyze the attachment. On the 4th carbon atom, the attachment we have there is ethyl. Ethyl, you can say that CH2CH3 or simply C2H5. Then this unit, the attachment we have there, of course, is substituent on substituent. 1, 2 carbon gives us ethyl. On the first carbon atom of this attachment, you have another substituent, another attachment on that first carbon atom. So that gives us 1 methyl ethyl. Attachment on an attachment. Alright, so we have on the 4th carbon atom, ethyl. On the 3rd carbon atom of the parent, we have 1 methyl ethyl. Which one will come first in the naming? If I ask you to locate ethyl in dictionary order and methyl ethyl, which one will come first? Ethyl will come first. E will come before N. Is that okay? And so the name of this structure is 4-ethyl 3 into, your parentheses, because this is substituent on substituent. 3 hyphen open bracket, 1 methyl ethyl, close the bracket, no other attachment. The longest carbon chain is 7. On the first carbon atom, you have OH. So that gives us heptane 1-O. So we go. So this is the name of this structure. Now, let me quickly say this. Some people reason that because the OH here is on carbon number 1, we may decide not to put 1O. We can simply say heptanol instead of indicating the carbon atom bearing that functional group OH, because the OH is on carbon number 1. So we now have something like heptanol. Apart from that case where OH is on carbon number 1, apart from such situation, every other case that OH is not on carbon number 1, you must indicate the position of the carbon bearing that functional group OH. Well, I am in no position to argue that concept of saying that this could still be heptanol instead of heptane 1-ol. It sounds reasonable. That would mean that once you just have the name directly like that without indicating the carbon atom bearing the OH, then generally, alright, one should know that the OH is on carbon number 1. However, on IUPAC level, we indicate where the OH is located. All the same, you are still okay. Wow, it's quite an interesting class, I want to believe that. If you have any question to ask, please kindly use the comment section, ask your question, and I will be right there to give a response to that. Do you think that you understand what you've learned so far under the IUPAC nomenclature of alkanols? Then of course you can take quizzes on these. In the comment section, once again, you have a link to a Telegram channel where we have the GMAT 41's quizzes for our courses. You can go over there and take the quiz on alkanols to see how far you can deal with the 5 structures we have in that quiz. It's alright, I will be seeing you in the next class where I will teach you the IUPAC nomenclature of alkanols or aldehyde, as you may choose to call it. Please subscribe to our YouTube channel, like, leave comments, invite your friends and colleagues to do the same. I would greatly appreciate that, so I will continue to move forward. You want full range of learning? You are free to always contact the GMAT 41, the number shown on the screen, or in the comment section, you can get a link to a Telegram channel that will guide you on how you can join our classes on Telegram. You have a wonderful time. See you in the next class.